So from that, I just did a save as of this project, and I brought it into, but I was able to, once I moved all of those zones back together, as you can see, I was able to actually get it to run some analysis. So this is a solar shading visualization of the building. And bringing those shades in will have an impact on the way that this solar shading analysis runs. But what this is allowing us to do is actually do an accurate solar visualization. So we're studying solar gain throughout the year on this building. And it's unlike some of the other softwares out there that have similar features where it's just calculating the center point and then applying that center point calculation to the whole grid, or taking select points within that grid. I can set how fine of a mesh I want just by telling it here, and it'll automatically create that grid and that fine mesh. Now, obviously, the finer the mesh, the longer the calculation, but it is an actual calculation of the entire mesh. So it does take longer for it to do the calculation, but it is also a far more accurate way to do solar analysis. So another thing that I can do is I can also put on my sun path. And the location that we've got here is a tropical location. If I pick the location, it'll obviously impact it. But if I want to study and understand the sun a little bit, I can start to parse through different times of the year, days of the year, times of the day, and really start to get a feel for the solar shading. Setting the location. Okay, so that's really easy. There's several ways I can do that. Probably the simplest way to do that is just from here with our location wizard. So now I can just go through, and this is Togo that it's currently in, but if I want to change it to, say, Maryland. So now I've changed my location, and if I want to change look at the view of this, I'd have to rerun that calculation. That takes a few minutes, but I can still just visualize the impact of solar. So you can see that it's quite a bit different, obviously, in Maryland than it is a tropical location. I can go inside of the spaces and dynamically view the solar behavior in the building. And this is actually, again, tied to the weather file and tied to the Suncast engine, so it's an accurate solar calculation and solar simulation. So that's, I've also run some simulations. I've created a simple HVAC system and run some simulations using the previous location, so using Togo. So if I want to look at my if I want to look at my results of the simulation that I've run. So this is just, I can simulate the whole year, obviously. It time steps down to a minute. But if I want to get an idea just from this about boilers and chillers energy here, for example, for that week, I can find out my boilers are coming on. I'm going to need some chillers here. I'm in Baltimore area. If I put on the outside dry bulb temperature, I can see why I'm going to have to start to get chiller energy. My dry bulb temperature is increasing outside, so I'm getting into some cooling times. This is a shoulder season, so I do have, I'm in that range where my economizer might need to be optimized a little bit more, although my dry bulb temperature is getting up in the 80 degrees here. So I'm going to need to look at doing some economizer optimization. But I can start to get an idea for energy, and I can sum that up so I can understand what my chillers and my boilers are doing, et cetera, et cetera. So that's like one of the first things that we'll do an analysis on, is to start to understand those types of things. But if I want to look at this just at a very, very early stage, even before I've necessarily even got a building, I can come in here and I can get an idea and a feel for what the climate's going to look like. So if I want to understand, do I have a heating-dominated climate or a cooling-dominated climate or a Mediterranean-type climate, I can run these analyses just very quickly and get a graphical representation of daytime temperatures, nighttime temperatures on a monthly average. Find out when my wettest times of the year are, etc. Getting a little bit further detailed breakdown as well on temperature ranges. So I've got a lot of hours actually in the range of 50, in a reasonable comfort range of about 60 degrees to 77 degrees. This is kind of in the comfort range here. But I also have quite a bit of cold hours, and I don't have an understanding of humidity. So if I look at this, I'll see, yeah, it's pretty humid in DC on a mean average. And if I look at my available wind resources, I might have an opportunity for wind here. The cutoff for wind is typically around 12 miles per hour. 13.5 feet per second is about 12 miles per hour. So I'm sort of on the threshold of wind being a viable strategy for this climate, or for this location. And then looks like solar might be a decent fit here too, based on the fact that my average annual mean cloud cover is about 50%. There's a scale of 0 to 8 octaves, 0 octaves being a perfectly clear sky, and 8 octaves being a perfectly overcast sky. So we're somewhere in between there. And that's probably pretty decent, and a fairly decent mean global radiation value. So that's a pretty high value. So a lot of sunshine that we might be able to use for PV in the Baltimore area. Other analysis I can run very quickly on this. I can get into bioclimatic analysis, whereby it's going to give me a view and a report on strategies that might make sense at different levels. So is it, design priorities? I've got to address the hot summer days. Got to minimize the summer day heating rate. I do need to address that there are some cold nights that I need to address. Microclimate. So if how do I want to orient the building? Am I in an urban pattern? If I am, what are the things that I need to look at? So 20 to 30 degrees oblique to summer wind. Modify orientation, increase street shading, etc. Where these strategies are coming from, you'll see these A's and these B's. If I scroll down, I get a reference to sun, wind, and light, and these section 59, page 167, and climate considerations, etc. So it's not just the program's actually looking through these reference materials and picking and choosing based on the climate and the building form what sort of strategies might be worth pursuing further. It's not going to be like a definitive list, because obviously there's tons of them, and not all of these would work based on my site conditions, etc. But of the millions of possible strategies, the software is helping me, sort through that, at least on some high level. Building materials, building metrics, so I can get an idea for the properties of the actual building. This will allow me to analyze things like how many rooms are within 25 feet of an operable window if I want to look at natural ventilation. It'll tell me what my effective depth of daylight is based on window height. And it'll also let me know how many stories my building is, what sort of materials to avoid, etc., etc. So this is going to take just a minute here for this to run. And it gives me this little report. So now that it's actually taken a look at this, it's letting me know that my solar loads are significant. I want to look at tightening up my envelope because I've got a leaky envelope. Internally load dominated, got 14 floors, so this internally load dominated is significant because I'll want to look at reducing internal gains as much as I can. So things like Energy Star equipment are going to be a good thing. Encouraging occupants to not leave the coffee maker on all the time, for example. Glazing's west dominated, 14 floors. My average daylit zone, average window head height is 6.9 feet, and my daylit zone is 7.8 feet. Distribution of the glazing. Half of my rooms are within 25 feet of an operable window, so that means that natural ventilation might be a viable strategy if the climate will allow for it, but the building form is allowing for appears to allow for a good natural ventilation strategy. So just again, some high-level things. Now this is all about the building. It's not about anything to do with anything else in the climate. Low to zero carbon technologies, I can start to input and study things like photovoltaic at different efficiencies and different square footages, wind turbines, solar thermal, ground source heat pump strategies. I can input a rate structure so I can start to get an idea for life cycle costing very early on. Do I have a combined heat and power strategy I want to look at? Proportion of the demand met. Just high-level analysis work. That isn't going to get into all the details of design, but gives me an idea about potential paybacks, how viable are these strategies, do I have any certified green power that's grid supply that I can take into account, and what percentage am I assuming that I'm going to have that meet the total load for this structure. Those are the kinds of things that very early on can be studied. So building energy, carbon analysis, heating and cooling loads. water analysis, looking at the lead credits can be done from here as well. And as we move into more detailed analysis, that's where we can jump in and start to get into things like a more detailed macro flow analysis. If I have operable windows, defining the properties of those operable windows, defining what types of windows I have, the percent operable area, for example, crack flow coefficients based on a pressurization, the length of the crack, and defining the profile for this thing to operate at. So if I do that, and then I can assign those windows, now I could run it. I could run this analysis. It's going to take some time, but let me just simulate again like a week, so it won't take an inordinate amount of time. So this should allow me to visualize some of the airflows moving in and out of these windows to get a feel for whether or not that's going to be a good fit for me. So if I do that and I grab my external vent, and let me just grab, let's just grab this one floor for now. I can start to see when the windows are opening, when they're closed, when they're closing, and it's based on a temperature profile. So as it gets warm enough, you see the windows aren't going to open when it's too cold, so when I'm down in my 30 degrees, the windows are closed. And then as it starts to get too hot, the windows close again until the temperature drops back down. So if I want to take a little more detailed look at Friday the 5th, so it looks like that as the temperature approaches, say, 75 degrees, the windows are closing until the temperature starts to drop back again below 75 when the windows open. And they're closing at night when the building is unoccupied. And the flow that I'm getting through there is 25,000 CFM. If I want to view that and air changes, I can change my units to look at that in air changes as well. And if I want to look at a data table of that, so how much I'm getting at every time step, I can look at a data table of that as well. And if I want to visualize that, I can visualize that from here and get an idea of windrows, get an idea for my windrows and the amount of flow at a dynamic simulation. So if I just pick the 5th, you can see I have no flow through my windows until I get to the appropriate time of the day where the windows start to open. You can see the values are changing and the size of the arrows are dynamically changing as well, and which windows are getting how much flow is visually represented. I have different ways of viewing that. I mean, I can change my arrow style, for example, so that they're round cylinders or whatever. So red arrows are indicating flow out and blue arrows are indicating flow in. I can change this so that I have like a wireframe to get an idea, a different view of where my air is coming in and going out and at what stories. Beyond just the analysis. But if I also want to like study some daylight, I can just pick. I'll just pick the top story here, and I'll calculate the daylight level just very simply within this space. But I can start to view these light levels and do my lead daylight calculation as well from here. And then I could also take this into, okay, it's going to give me a report saying the calculation was successful, so let me grab all my stories again, and let me flip this to plan, and then I can cycle through these stories and see where my daylighting and how far it's penetrating into the space, and I can view this in different ways. Filled contours, or I could say a threshold contour, so only show me the areas that are above 2% daylight factor or below 2% daylight factor. So I get an idea for how well my daylight strategy is working. And it's not working so great on this because of the depth of the floor plate and the relatively small amount of glazing that we have on this building. But there are some areas like in the perimeter where it could be beneficial. I could also take some time if I wanted to and place artificial light fixtures in here to do a combined analysis if I wanted to. But if I wanted to make a rendering of a particular, outside the building or of a particular space, I can go into here and I can say get your position, and I can navigate around And I could get an idea for what this room would look like from a brightness perspective, and I'll just make a very quick one here. Now, if I cranked up the resolution or the quality, it would be like a photorealistic rendering, but that would also take a few minutes. But I can start to get into here, what are my light levels at these different points, for example. I can study glare from here. I can also show some contours of light, contour lines, etc., and get an idea for where my light levels are falling in the space. I can make a false color image of this. It's the full application of the Radiance engine from LBL, Lawrence Berkeley Labs. It's just integrated into the VE with a graphical user interface. I can do microflow for CFD inside and outside the building. So if I wanted to study air currents around the building, for example, get an idea here for how the air is moving around the building.